This section of my plot is the RAM experimentation area, where I've tested lots of different designs for making RAM cells and checking how well they stack together, and and dealing with engineering challenges involved with placing repeaters, and it it's actually it's kind of complicated, to be honest, but well, that's what I do. Okay. Uh, so here is the latest iteration, or the latest design of 2x2 piston bud RAM, which I've settled on. It You have data goes in, so here's a 1, and when this piston extends or retracts, that causes an update for this piston, which then extends, cutting the wire. Oh wait, I'm missing a block. There we go. So it cuts the wire, giving a 0 to this piston. And when this piston, it's a piston inverter here. When the piston is retracted, it stops cutting wire and lets a signal through. But it's much more helpful if you can watch the process of how it goes together. It's just how the human brain works. So, and I'll do this color-coded. First comes the output line, where the data comes out. Second comes, and I use magenta for that, reddish or magenta-ish. It's just the color code which I it's arbitrary colors which I used in my first invention of when I was first inventing RAM, and I've just kept with it because having a consistent color code is nice. Right. So red here I'm using for power supplies, and there are 2 power supplies in this. One. The reason I need power supplies is because I'm using the way the piston logic is set up. It's using wire cutting, and where a block goes down and cuts the wire, and so it can't transmit charge anymore. But cutting a wire doesn't do anything unless the wire is powered, so the wire needs a power source. So there's the power source, and there's the wire which will be cut. Now, let's add the thing which will cut it. Right. Piston. I love block sampling. 1.25 was a good update. Yep. So piston goes down, and the wire's cut. Piston goes up, and the wire is uncut. It's connected. So whenever an output piston is retracted, a 1 is going to be sent. Whenever a read control piston is retracted, a 1 will be sent down the output. The way RAM cells like this work is that they get tiled in 2 dimensions. One direction is the data direction, where the inputs and outputs go. The other is the control direction, where the controls for each memory slot, you have to keep a continuous wire for each memory slot, so that you can read from the entire slot at once, and you can write to the entire slot at once. Memory isn't really useful unless you can do big batch operations like that. Right, so that's the output control. That's good. Now for the data reading. And you'll note that these wires are connecting. This is not a thing I want. So I'll get some insulation. Bam! Now they're not connecting. but both of these wires on their blocks are going to be acting as inputs to this piston. This piston is going to be acting as a NOR gate, which means it will only be retracted and sending a 1 if all inputs are 0. Okay, now the upper power supply. And you'll see that this automatically extends that piston. Okay. The right control. Oh wait, no, I need... There. Okay, yes, that it's a little tricky putting this one in, because the data piston here, this is the piston which stores the 1 or 0, doesn't have a block exactly next to it. Oh, and this should be glowstone. Okay. And now the final piece, the input. The input line has to zigzag up and down, which is, it's not something I liked, but it was, there wasn't a good other way to do it. Not without adding much of slowness to the entire contraption. It has to zig up in order to get over the right control, and it has to zig down again in order to have a powered block close enough to the piston that the piston can detect it. So this is the input, the right control, except it's still missing something. Do not forget this. This is the thing which actually does the updating. This piston. When this piston arm moves out, there's an update next to this piston, next to the data piston, and when this data piston gets an update, it then looks, am I getting charge from anywhere? And the answer is either yes or no based on the power state of this block. So I can do a crude verification. Input, and yep, it gets written, and I can control whether the data is being output or not. Okay, that's good. Now let's copy this a bunch. Okay. Now that we have a large chunk of it, you can see how RAM starts to shape up in the large scale. So I'll write 1100 to the first one, to the first input. Actually, I need individual write controls. Okay. And you can see the state of the pistons is 1100. Now comes a bit of a challenge. All of these output lines, all of these read controls should be on. But you'll notice that I can't just turn this off and have pistons retract, because each read control line is actually affecting both neighbors. Normally, this would be a serious problem, and it was a really serious problem in earlier designs with the write control, which was writing to both of these. But the output is a little bit more forgiving. What you do here is you make sure that a pair of lines are off, and that allows the middle one to that allows the slot or the pistons in between it to retract and output. So they retract if they have a 1, and they don't retract if the data that was stored was 0. So here in the first one we have 1, 1, 0, 0. That's good. And you can see that if I change the data, you can see, well, that works. I can change it. Now in the second register, I'm going to do 0, 1, 0, 1. Nice. I have to actually write it. Oh, let's get a little view in here of what's going on when I press this. Yeah, see that piston at the end. That's good. Okay, and you see the state is 0, 1, 0, 1. And to read from this one, first let's stop reading from that, and then we select both lines adjacent and turn those off, and retraction happens here, and the output is 0, 1, 0, 1. Excellent! So, that is how you go about making 2x2 footprint piston bud RAM. Yes, that's a bit of a mouthful. 2x2 footprint piston bud RAM. Now, there are a number of variations of designs, but this is the one that I've decided I like the best. Because, well, I invented it and I've tested lots of stuff. Anyways, I like it. And now, hopefully you, the watcher of this video, know how to make it for your own projects. Turning off a pair of adjacent lines can present a bit of a technical challenge. Since how do you control pairs of lines from a single input? And the answer is, well, this device here. When you select a line by sending a 0, a torch turns on. It activates both wires next to it, which shut off a pair of torches. So this torch turning on means that all the pistons along this line are now have the ability to retract. This is just the output control of the RAM, because it's easier to see what's going on. The yellow blocks here, it's just a slice. The yellow blocks here represent 1s, no blocks represents a 0. So the second line, 0, 1, 1, 0. And we see on the output 0, 1, 1, 0. So, it's a good system.